So now would be a good time to kick off the webinar. You're all very welcome. Today I will be talking about simulation-driven design for automotive and aerospace industries, utilising the power of Simcenter 3D motion. I'm Donogh O'Malley and I'm your presenter. I'm an engineering solutions consultant for Kaizen PLM. Just to give you a background on Kaizen PLM, we are an Irish-based Siemens Digital Industries Software Gold Partner. We provide solutions and support solutions for CAD, CAM, CAE analysis, virtual commissioning, technomatics, MCD, additive manufacturing, Teamcenter, Polarian, Mendix and Keyshot. We are a specialist partner for the additive manufacturing portfolio from Siemens for the UK and Ireland. We also provide 3D scanning services, so we can provide a service of scanning components for you, or we can provide the hardware for such scanning. As you can see on the slide here, the Siemens software portfolio offers a lot more than just CAD. Siemens are the largest engineering software company in the world and offer everything from manufacturing execution systems to electronic design and low-code app development platforms. As we can see on the top left for mechanical design, we have NX, Solid Edge, FiberSim, SynchroFit, MasterTrim, Somatic IT, R&D. Within NX, obviously, we have the CAD CAM. We also have simulation analysis tools within that, and the same as with Solid Edge. Under the software portfolio, there's solutions for a vast array of applications for electronic design automation, software delivery, simulation and test, performance analytics, manufacturing operations, automation, manufacturing planning, and all these can be made work together in collaboration using Teamcenter and MindSphere. Let's focus in on the ideation phase, where performance engineering plays its biggest role in the product development process, and discuss a bit more how performance engineering also needs to evolve to support the concept of a holistic digital twin. First, it is clear from the trends that today's companies are dealing with increasingly complex systems and technologies, so it is critical that the tools they use deliver realistic representation of their product to give confidence in their designs and their design decisions. Second, to support the digital twin, it is critical that performance engineering processes are not isolated and disconnected from the rest of your organization or the PLM process. We need to connect people, projects and data. If companies are able to reduce barriers, they not only increase their process efficiency, they also get a more holistic view to make the right decisions with all stakeholders across the organization, and are able to close the loop with and complete the engineering cycle. Finally, having a realistic integrated process and models today is not enough. You also have to be able to deploy them so that they bring necessary insight to make decisions and do it quickly. So companies must have the ability to intelligently explore the design space to quickly trade off and discover better designs. This, of course, also means that we need to be able to interrogate the information from these hundreds of designs to make the decisions. High quality analytics as well as visualizations are also critical to make the simulation usable and accessible. And of course, the backbone of all of this needs to be a set of streamlined and automated workflows, consistent interfaces and efficient processes that reduce engineering time and allow engineers to spend their time where it matters, innovating. When companies transform their performance engineering processes in this way, they're able to engineer innovation. Ultimately, What this means is that they increase their market agility to bring better, more innovative products to the market faster and at a lower cost. This is what the Simcenter portfolio helps our customers achieve. So how does Simcenter 3D realise this vision? First, let's look at how the portfolio delivers realistic models and increases model confidence. Simcenter brings a wide range of physics and disciplines together under one umbrella. Through its multi-fidelity solutions, including system simulation, CAE simulation, and as well as efficient testing solutions, Simcenter covers all stages of development and leverages the tools together for a better product representation. Finally, we ensure that the solutions in Simcenter work together and embedded the necessary technologies to capture specific industry challenges. By using all these capabilities together, engineers can be sure that predicted performance of their product will match real-world behavior. Let's look at how the portfolio focuses on delivering insight. Simcenter includes an efficient and easy-to-use intelligent design exploration framework that easily integrates with your current design and simulation tools and fully leverages your HPC infrastructure. Simcenter also enables high-quality data and analytics to gain insight into data from many sources and make informed decisions. Simcenter includes dedicated post-processing and visualization capabilities to broaden the comprehension of the results. Let's look at how the portfolio enables enterprise collaboration. With Simcenter, you're not limited to the solution we offer in the portfolio. It is open to enable seamless co-simulation with other tools that companies already use. With Simcenter, the solutions can leverage the Internet of Things to interrogate sensor-based data with high-fidelity, physics-based simulations, allowing manufacturers to build and maintain digital twins of their products and to keep them in sync with the physical product in use. This is of crucial importance to making more useful and realistic predictions of product performance that will enable these products to adapt to changing usage conditions, extend their useful life, and accommodate product degradation. Engineering teams today are generating huge amounts of data, and in order to be effective, this data needs to be managed and tracked. Simcenter is integrated with Teamcenter simulation process management to help engineers manage their models and data and keep them in sync with the design. Let's look at how the portfolio focuses on your productivity, helping you save engineering time and accelerate your return on investment. The portfolio offers complete deployment flexibility to the user. This is achieved through flexible licensing to ensure companies can maximize the value of hardware and fully leverage investment in simulation technologies with HPC. The portfolio is supported by engineering services and support engineers. Our team of technical experts has a broad engineering proficiency to help you achieve your complex design goals and deploy innovative engineering processes with Simcenter. Simcenter delivers streamlined and collaborative workflows. This ensures that the portfolio is easy to use and minimizes the learning curve and your time to be operational. Industries, processes and challenges. There's a need for high reliability, quality and performance. Products are more complex and expensive. There's a large variety of platforms and raised customer expectations. Lower product development costs are essential. Optimize not only unit cost but cost over life of the program. Reduce testing and use testing more to validate simulation. Create products using simulation and without costly prototypes to speed up development. Develop new products faster. There are more appealing products than the competition. Make products more innovative and ensure their market appeal. deliver breakthrough performance better than the competition, say like fuel economy, power, speed, or reduction in weight. The machinery industry trends include the growing complexity required by customers, global competitive pressure from new low-cost providers, end customers' demand for customized products driving demand for customized machines, and regulatory pressures driving machine design. These trends are causing a fundamental change in machines and how they're being designed, built, and serviced. This has clear implications on trends, and the machines simply need to be smarter. To address the low-cost providers, pricing adjustments put already low margins under pressure. With customized machine requirements comes a requirement for greater innovation, and the regulatory pressures mandate compliance only add to the already complex machine design and manufacturing process. For manufacturing to develop smarter machines, they need to consider opportunities to utilise a collaborative and parallel engineering platform, more efficient manufacturing processes, modernisation of machines to support reuse and mechatronic design requirements. The ideal solution set to capitalise on this greater innovation pressure provides integrated software, mechanical and electrical design, virtual commissioning, capture all model features, and capture as-built configurations for traceability. There are 5 ways that Simcenter 3D is different than traditional simulation tools in use today. First, Simcenter 3D begins with the engineering desktop, which is the integrated environment in which you do all of your pre- and post-processing. Within this environment, Simcenter 3D offers best-in-class geometry editing tools, comprehensive meshing, and a unique ability to associate the analysis model to design data. This helps engineers speed the tedious modelling process and keep analysis models in sync with the latest design. This then translates into faster design analysis iterations. Simcenter 3D then delivers accurate multidiscipline simulation from within the centralized engineering desktop. Simcenter 3D simulation solvers help you to predict real-world performance. Simcenter 3D's unified environment is completely scalable and extensible. This means that the same familiar user interface is applied to all solutions and reduces training costs for the department. It also gives a common environment on which to build automated routines to drive simulation processes. Next, Simcenter 3D can link with your broader systems, engineering processes, and tools for 1D systems and physical testing. Simulation data management lets you track information throughout the development process and can help you correlate your 3D simulation models with your 1D system models and physical tests to deliver confidence that your simulations predict real-world performance. And finally, Simcenter 3D's common interface means it's much easier for engineering departments to capture simulation knowledge and leverage that industry expertise by automating it and deploying it to a broader team. This can help simulation teams become more flexible and adjust resources to meet fluctuation demand. Simcenter 3D's integrated solutions also incorporate Siemens' own industry expertise that has been gained over decades. How can Siemens help you meet the challenges? Siemens provides the world-class CA simulation software analysis tools needed to predict complex behavior. It provides product training, modeling, and test experience needed to educate, support, and advise your engineering team. Provide engineering services as an option to meet your manpower and technical expertise needs. Siemens Solutions, more insight by test and simulation, scalable solutions, widest possible integration, customizable an open platform. The benefits: more insight to optimize total program costs, more insight to build in future growth compatibility, scalable solution to handle wheels, track, manned or unmanned vehicles, customizable for complex operating environments, an open platform for integrations. Front-load designs, multi-body simulation from the beginning of the digital development process. We have close connection to design tools and scalability. For mechatronics, increase in complexity of electronic systems. The solution: easy integration of control systems in mechanical models. Real-time simulations, early integration of flight simulators in the design cycle. Solution demands real-time capable models with high level of accuracy. Motion study is based on a skeleton wireframe concept. Results of the motion study are giving the CAD specifications: components, mass, properties, mass, inertia, gravity center, joints, orientations and positions. The motion skeleton is generated following the whole product requirements. The skeleton model itself is a parameterized template in order to generate a family of models. There could be different templates per sub-product architecture type. Reusability of the same skeleton generated model. Drive multiple revisions of the same product due to performance optimization and technical specifications. Also used for multiple configurations of the same product and mass properties. Can be used for multiple or different products. Because Simcenter 3D is built using the same foundation as a CAD system, it has a much more powerful geometry editing capabilities than traditional motion tools today. First, Simcenter 3D can take an NX CAD assembly model and then automatically convert the CAD models into a motion model. Each assembly component will represent a link within the motion model, and Simcenter 3D will convert the assembly constraints to proper motion joints. 3D contact can also be defined between each part of the model, and the contact definition will take the actual geometry into account. The motion model is entirely associated to the base NX CAD model, so it is possible to update the motion model whenever the base geometry changes. This allows engineers to stay on top of design changes and speed the design analysis iterations. And power and intuitive geometry editing capabilities like direct geometry editing using synchronous technology lets engineers try what-if type scenarios themselves without having to go back to the design team to make changes. The NX CAD integration, it is CAD agnostic. Quickly convert CAD assembly to a functional motion model. Assembly constraints converted to motion joints, 3D contacts between bodies. Stay associative to design. Support for all major CAD formats. As we can see here, we have NX CAD, CATIA, Solid Edge, SolidWorks, JT, PowerSolid, Steps, IGES, ACES and AutoCAD. And we can also use synchronous technology for orphan CAD editing. So it doesn't matter what CAD format you bring in, you can still use synchronous technology to make these edits. And in a lot of cases, these edits are easily made and easier to make in NX than in the native CAD. Motion analysis, otherwise known as multi-body dynamics, is the study of the behavior of interconnected rigid or flexible bodies, each of which may undergo large transitional or rotational displacements. Motion analysis can be broken down into two major types of analysis. Kinematics, study the motion of objects without reference to the cause of motion. Does not take mass, inertia, forces, torques, and others into account. Dynamics, study of forces and torques and their effect on motion. Here we have the Mars rover being simulated going across various terrains, inclines, and dips. We also have the 3 sets of wheels rotating around to ensure true efficiency and stability across the uneven terrain. Simcenter motion is to be used to improve mechatronic systems by giving a user a set of tools to predict and analyze the positions, velocities, accelerations, as well as the loads of the system. This is accomplished through a robust 3D environment linked to a proven, accurate multi-body solver. A good way to summarize the main characteristics and benefits of Simcenter Motion is probably a complete and integrated multi-body solution to simulate realistic motion and loads of mechanical systems, allowing to quickly analyze and optimize the real-world behavior of mechanical design and to verify that it performs as expected before committing to expensive physical prototype testing. By detecting any problems early in the design process, Simcenter Motion allows also to front-load the possible solutions as well as to explore limits without putting people or expensive equipment at risk. It provides leading-edge technology in solid modeling, parameterization, CAD geometry, flexible body features, control and hydraulic capabilities, solver performance, animation and post-processing capabilities, all integrated into a single user-friendly desktop environment, eliminating the need for multiple solutions and time-consuming data transfers. The elasticity of subcomponents of a mechanism can be incorporated by means of linear mode sets. Different ways to obtain those include finite element pre-processing, or the usage of test modes from experimental modal analysis. Mode sets which are derived from tests can be correlated to FE mode sets to obtain the highest certainty to capture the correct physical behavior. The full range from test hardware to post-processing is covered by LMS products, and our engineering services accumulated experience in this field, being the world #1 in ground vibration testing for decades. The need to simulate many different load cases in different scenarios for potentially alternating design variants calls for individual customization. Besides the inbuilt possibilities of NX Open in terms of scripting and the use of parameterization of models, another solution is offering our customization team, which offers dedicated customization services projects, for example, to create a simplified user interface and cut down the modeling and simulation effort by orders of magnitude, allowing to focus experts on the template modeling and analysts on the evaluation of load cases. Complex models of actuators, say hydraulic or electric, and corresponding controls can be linked to Simcenter Motion model in order to dimension actuators and shock absorbers. By computing the forces and torques needed to generate desired mechanism motion, for example, landing gear retraction or opening, closing of a door, or actuation of a high lift device. Correlation for validated flexible representation. Dedicated application to efficiently carry out key correlation steps. Pre-test. Improve test quality and speed up test setup by obtaining best set of measurement locations and best set of excitation locations. The correlation. Compare, understand and evaluate correlation between test and FE data. Qualitative comparison and quantitative correlation of data. Sensitivity and updating. Retrieve candidate design parameters to improve correlation. Simulate, optimize, build. Validate landing gear performance with virtual test. Gain full insight from co-simulation with physics-based libraries in Simcenter MSim. Correlate models with measurement data. Here we have the landing gear with loose dampening By decreasing the dampening, one can decrease to some extent the loads on the landing gear, beams and struts and connection points in the fuselage, but the landing gear might experience bouncing off the ground, and this will induce less plane control and less passenger comfort. And here is the result of what stiffening up this dampening effect does to the system. By increasing the dampening, one increases the loads on the landing gears, beams and struts and connection points in the fuselage, and it will deform harder as a result, but instead the landing gear will experience less bouncing off the ground. This induces more control and provides stability to the overall landing effect. Now I'll describe some of the disciplines and applications which are offered by Simcenter 3D. Let us start with the structural analysis. Simcenter 3D capabilities include metallic but also composite materials. It can be applied to fuselage, wings, but also what we call large FEM assemblies, very useful so to facilitate cooperation between OEMs who will manage the FEM assembly and the global model, and the risk-sharing partners who will provide the different FEM models of their own components. When designing composite components, we may also mention the capability to simulate manufacturing processes and phenomena like curing and springback. Damage-tolerant design is an important concept for airframers as it allows to take full advantage of the material's capabilities to support loads. We provide everything you need to support this design methodology for composite components where delamination and damages are allowed to grow, but in a controlled way. Motion is another discipline offered by Simcenter 3D. Wing flaps combine CFD and structural analysis to assess the structural performance, but simulation must also study the motion mechanism of the flap to make sure it responds correctly. Simcenter 3D offers thermal and flow analysis. An example of the application is this simulation of the cabin HVAC system and how it performs so that passengers will feel comfortable. Simcenter 3D's coupled thermal flow analysis capabilities are part of a more global multi-physics solution, including also structural and motion analysis. Finally, NVH and vibration analysis are important disciplines so to ensure comfort of every passenger. Jet engines are of course the main source and can be analysed thanks to the rotor dynamics capabilities of Simcenter 3D. This example here shows us an electrically controlled sunroof of a vehicle. The control strategy was developed in MATLAB and is used to control the motion simulation. This is verifying that the control strategy is effectively controlling the physical mechanism and that the mechanism is operating as required. We can see the various components activating and behaving as they are being controlled by the control strategy, and this is also validating that the control strategy is correct and driving the mechanism in the correct way. This is a fine example of co-simulation where we initially built the 1D control strategy, and from working through and building up the CAD models, we are now able to verify that the control strategy is correct and driving the mechanical components correct. It's also testing that the mechanical components will behave as required when being controlled by the electric strategy. Here is another great example of how Simcenter 3D can safely test the control strategy as well as the mechanical controls. Here we have the sunroof operating, and sensing where there's a arm in way, and then it's testing that safety feature. Now, this can all be done prior to any prototype, so we can ensure that the safety control within the control strategy is correct and that the mechanisms will behave as expected and there will be no surprises when we build the prototypes. This saves an awful lot of time and an awful lot of money because we can run these checks, we're not risking anyone and we're not risking any expensive prototypes, and we can easily see how effective the 1D strategy is at safety. Another example of how NXCAE supports systems level modeling is in the area of co-simulation of mechanical systems with controls. Control engineers need good models of the mechanical system in order to test out their control algorithms. Conversely, mechanical engineers need the ability to simulate the motion of their mechanisms with controllers. NXCAE enables both these scenarios and is today the only system that integrates design, co-simulation and flexible bodies into a single environment. Discover and resolve problems earlier in the design cycle. Investigate situations not possible before. Simcenter 3D Design Space Exploration. Here we set the geometry, the material choice and the properties. Simcenter's 3D Design Space Exploration will automate the CAE process, using the Sherpa library of algorithms for fast design space exploration strategies. In this example, we're to minimize the mass while satisfying the CAE constraints with the stress and the strength, etc. The only variable is the CAD geometric parameters. And here we can see each iteration being simulated and analysed simultaneously and the changes being made to get as close to those outlined parameters as possible while satisfying all the other design requirements. Revolutionary real-time capability for Simcenter 3D motion models. Unlock new external model integration possibilities. Add a model to a RT platform. Integrate with other multi-physics models. Combine with RT simulators or hardware in-loop. Reuse existing models or extend the accuracy of RT models by adding more DOF than ever possible with previously reduced models needed for RT performance. Validate both the mechanical systems and the control systems on the basis of the same 3D high fidelity models across teams. Clear process time savings, increased frequency and load range, decreased uncertainty from multiple models of the same system. Deliver real-time simulations with multi-body simulation models using graphically created 3D CAD-based models or 3D analytical models and mode-set flexible bodies. Real-time model performance from the Siemens NX platform with Simcenter 3D Motion for external real-time platform. Integrated design and analysis pays off on the design of NASA's next generation launch vehicle. The use of Simcenter 3D Motion and Simcenter 3D in an integrated design analysis process managed with Teamcenter helped engineers ensure that a larger nozzle won't hit launch pad structures during liftoff. Here we can see there's faster creation of analysis models. Analysis plays a greater role in the design process, higher confidence and accuracy of analysis models. Integrating CAD and CAE without data translation is a win-win for everyone. Not only are we saving time from translating from one file type to another, we're also eliminating the risk of working on out-of-date data. The main intent was to use Simcenter 3D motion to capture the time and sequence of the rocket taking off and the retractable launch mounts moving back. Here is an example of the development of one of the Mars rovers from JPL. JPL faced development challenges with the latest Mars rover in the form of a tighter development schedule. It's also the most complex rover to date with more moving parts than before. In order to meet the schedule, JPL needed a simulation tool that will let them adapt rapidly to design changes and provide faster design analysis iterations through close collaboration between engineers and designers. They chose Simcenter 3D for these reasons, and Simcenter 3D's motion analysis capabilities were used to study the various moving parts of the rover. The business challenges were tighter schedules and more moving parts. The keys to the success is the single software platform, NX from design through manufacturing, digital assembly model of entire Mars Science Laboratory, multidiscipline simulation with Simcenter 3D software. The results: faster design analysis, redesign iterations, less manual work and less rework, increased efficiency, more confidence in the hardware modeling, the design implementation and the mission simulations. Utilising NX and Simcenter 3D really gave JPL the edge and provided the tools to optimally deliver an extremely intricate and challenging design that not only had to perform after a series of events from takeoff, traveling to Mars, and then the deployment on the surface of Mars. It also has to be reliable to ensure that this whole process is confident and reliable to ensure that we can gather the information that's required should humans ever travel to Mars. Simcenter 3D multi-attribute engineering performance resulting in an integrated CAE simulation platform, engineering desktop, CAD import, editing and cleanup, meshing, assembling, property settings, run preparation and monitoring, and simulation post-processing. Solvers. Here we have the many solvers: Simcenter Nastran, Simcenter SAMSEF, Simcenter 3D solver environments, MSC Nastran Abacus, and LS Dyna. We have linear and non-linear, FEM, BEM, motion, thermal, and CFD, multiphysics, test CAE correlation, co-simulation, Simcenter MSIM, and Simcenter Star CCM+. Vertical applications such as structural analysis, acoustics, NVH, multibody, driving dynamics, durability, thermal flow, and electromagnetics. Teamcenter for simulation, so we can combine all of these and have them work together and have all the data stored under the one roof and being monitored under the one roof with Teamcenter. Link with design, engineering desktop, the solvers and the vertical applications are associative to design for rapid updates, quick creation of new geometry required for CAE analysis, convergent body integration with NX modeling, native link with NX, multi-CAD support, best-in-class geometry editing, intuitive and fast. Knowledge of part construction and features is not required. Synchronous technology, edit data from other CAD systems faster than the competitors. Simulation in a managed environment. So Here we have the requests, so we have the CA simulation management, the product data, the configuration, the simulation data, the simulation tools, the simulation workflows, requirements and schedules. We can see the designers and program managers going over and back, the analysts going over back, and then we have the simulation applications there ready to go. The simulation data management and traceability is tool independent. Simulation assemblies management and automation. Simulation workflows management, execution of integrated tools where we work together, and there's outline workflows. Simulation results. We can easily grab the results with visualization and easy reporting, so we can ensure that the data is being presented in a concise way to save time and for clarity. Openness for customization and automation. Completing the last mile to address specific customer challenges. So there's specific post-processing, dedicated UI for editing specific elements, and integration of additional steps in specific simulation process. Workflow automation with up to 80% time savings for repetitive tasks. Seamless integration of customers' legacy methods and tools. Produce tailored interfaces and deploy simulation solutions to non-experts. NX Open enables scripting, journaling, automation and customization. If anyone has any questions or any queries regarding the software, any of our solutions, or are looking for any trials, please direct all questions or queries to either donna@kaizenplm.ie or support@kaizenplm.ie. Either myself or one of my colleagues will take the questions, and we will also set up meetings as required to outline trial plans, training and any solutions. To stay up to date with all of Kaizen PLM's activity as well as Siemens, follow our Facebook page, which is just search Kaizen PLM, the same with YouTube and the same with LinkedIn. Also, for more detailed information on our services and the software solutions which we support, please visit our website, which is kaizenplm.ie, or for additive manufacturing solutions, please visit kaizenam.co.uk. Thank you all very much for joining me today. We really appreciate the support and I hope you enjoyed the content. Again, any questions or queries, please feel free to email me or contact any of my colleagues, and visit kaizenplm.ie to see all of our solutions. If there's anything that you'd like to set up or speak about, please get in contact and I will be happy to help. So that's it from me today. Enjoy the rest of your day and I hopefully get to work with you in the near future.